This video lesson is going to discuss different types of triangles and angle theorems that arise while dealing with these triangles. So the first thing we need to be able to do and things we need to know is how to classify a triangle by the sides that it is given. So for a scalene triangle, I'm not going to have any sides that are congruent. A, B, and C will all represent different lengths. For an isosceles triangle, I'm going to have two congruent sides, which is represented in my picture by the single tick marks. And for an equilateral triangle, you notice that all three sides have a tick mark, which means all three sides are a congruent measurement or a congruent length. If I talk about classifying these triangles by different angle measurements, I have an acute triangle. That's where all three angles are going to be less than 90 degrees. I have an obtuse triangle where there's one angle. We'll call that angle theta. That angle is between 90 degrees and 180 degrees. Equiangular means all three angles are congruent, and in a triangle that means all three angles are 60 degrees. And finally we have a right triangle where one angle is 90 degrees exactly. A little bit more information about an isosceles triangle. So on an isosceles triangle, there are two legs and a base. So those three pieces of information represent sides. And based on what we saw earlier, I know that those two legs are congruent. I have a vertex angle, which is the angle created by the two legs joining together. And then the base angles are opposite from the congruent legs. And these angles here are congruent as well. So this is just some terminology that you need to know. I'm sure you've already seen this theorem at some point in time in your math career. They may not have stated it to you as the triangle sum theorem, but the sum of the measures of the interior angles, so all three angles added together inside of a triangle, will add up to 180 degrees. And we are going to use that to determine the measure of angle P based on this picture. So in order for us to do that, I need to take all three angles, add them together, and set that information equal to 180. So I'd say 15x minus 4 plus 4x plus 5 plus 65. All of that has to be equal to 180. From here, I would combine like terms, and my goal is to get x by itself. So this would be 19x plus 66 equals 180. So this would then lead to 19x is equal to 114, which ultimately tells me that x would be equal to 6. But they didn't want us to find the measure of the variable x. They wanted us to find the measurement of angle P. So I would take the value of 6 and substitute that back into where I see x in the angle P expression. So I would have 15 times 6 minus 4. So the measure of angle P would be equal to 86 degrees. So that would be my final answer in this case. And I'm going to give you this picture, and I'm going to step aside, and. And I'm going to let you try this one on your own. and bring the answer back to class with you tomorrow. And your goal is to find out what this angle up here is in terms of a degree measurement. The next thing that we're going to talk about is a corollary to the triangle sum theorem. And what that means is this is a branch off theorem that we can use. This is it's a good way to say it. Corollary is a branch off of the original theorem that we have already discussed. So this is true based on the information that we've already talked about. So acute angles of a right triangle are complementary. The reason this works, or the reason that this is true, is because I already have the right angle being 90 degrees. So therefore, the other two angles, in order to add up to 180 degrees total, have to have a sum of 90 degrees. And so if you look at this picture, I have 2x in this corner and x in the bottom corner. And this is a 90-degree angle. Now you could say 90 plus 2x plus x equals 180. But because I know that these two acute angles also have to be 90 degrees, I could say that 2x plus x equals 90, which gets me to x being 30, because this would be 3x. So in this case, because x is an angle measurement, I'm going to say that x is equal to 30 degrees. So this would have to be 60 degrees. So these are some more angles and vocabulary that will come up. Now in this case, you notice that I have extended the side of the triangle along the base so that I'm looking at the exterior angle, which is this piece here. So it's created by the side of the triangle and this extended base, and that is where the exterior angle lives. And the reason that I need to know these terms is because I have a theorem called the exterior angle theorem. And that tells me that if I have an exterior angle, that measurement is equal to the sum of the remote interior angles, or the two non-adjacent interior angles. Those two statements, those two terms, non-adjacent interior angles and remote interior angles, they are able to be switched back and forth for each other. They are synonyms of one another. So if I use this theorem on a picture like this, so now I have these two remote interior angles, or non-adjacent interior angles, and I have the exterior angle of 2x minus 8. So I can say that 48 plus x, which is my two remote interior angles, is equal to my exterior angle of 2x minus 8. And this ends up giving you that x is equal to 56. And again, because x in this triangle is a degree measurement, I'm going to actually label this as degrees. If it is just x being a variable, I'm not going to label it with degrees. And I'm going to give you one more picture where I can use the idea of the exterior angle theorem. I've tweaked the picture a little bit to make it a little bit more challenging. But your goal, I don't think you can see this in the screen, your goal is to find x, y, and z which is these three angles along the bottom. And I want you to go about doing this in two different ways. So you can use the exterior angle theorem, but you can also use triangle sum. But I want you to try to do this in two different ways. And we'll go through this problem in addition to the other problem that I gave you in the video that I did not solve. We'll go through those in class tomorrow and then practice with these some more.